Hey guys, hope you're well. Here we have another exam paper. If you want to download the paper, just check the description below the video. With question 1.1.1, these are ones that can normally just factorize very easily. So if you had to factorize this one, you should eventually end up with x minus 6, x minus 5, and then you can say x minus 6 must be 0, or x minus 5 must be 0. Therefore, x would be 6, or x would be 5. With 1.1.2, whenever they say correct to 2 decimals, then you know that this is one where you are going to have to go use the quadratic formula. So the quadratic formula is x equals to negative b plus minus square root b squared minus 4ac over 2a. So remember that your first step is to make sure that everything is written on the one side so that you have a 0 on the other side. So that step has been done. The next step is to then realize that whatever's in front of the x squared is your a, whatever's in front of the x is your b, and everything else is your c. And so we'll just go full in. So we'll say minus 9, and then b is 9. Whenever b is a positive number, I don't really worry about the brackets for it, but you can use brackets if you want. But if b is negative, then you have to use brackets. Otherwise, it's going to cause problems. So if you want to just use brackets every time, that's also okay. I'm just trying to save paper or my pen, so I don't feel like putting brackets today. I'm being very conscious about how much ink I'm using right now. So, and then C would be 4, and then A would be 3. Okay, so that's all that you need to show them. Now you can just go use your calculator and go get your two different answers. So your first answer that you get should be negative 0,54, and then for the other one, this one would become negative 2,46 if you round to 2 decimals. When learners look at these, they instantly get panicked about it because they don't really know what to do. But let me just explain. I've seen these ones happen so many times. They all follow the same strategy. So what we need to remember is that I've seen so many, like for example, they'll do something like this. And then they'll go like that. And then learners don't know what to do because this part here is awkward. But the way these questions work is the following. You need to look at the exponential part, which is here. And in this example, it's over here. And then you need to just think about that expression. So that is the expression 2 to the power of x. You can go plug any number you like into that x place over there. That will never ever give you a negative number. Never. It's impossible. So if I had to show you what that looks like as a graph, it's just a normal exponential graph. And so if you look at the y values, positive, 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 you'll never see this graph under the x-axis. So this, no matter what x value you plug in here, this will always be a positive. So that's the first thing you would tell the examiner for a question like this. You would say that 2x is greater than 0 for all x values. Okay, so if this is always positive, then if you want this whole expression to be smaller than 0, which means negative, then if this expression is always positive, then it means that this expression would always have to be negative. And then you would just say, therefore, x minus 4 always has to be negative. And then you just go solve that part, because a positive times a negative is going to be a negative. And so it's the exact same strategy that we're going to use here. Step 1, you need to analyze this thing. This won't always be a positive. This could sometimes be a negative, depending on how they've done it. So let's just go and analyze this and make sure we understand what that looks like. So that's a half to the negative x. Now, you can think of this, if you like, as a half to the negative 1, and all of that is to the power of x. Because if you multiply these two, it still gives you negative x. But now if you had to go type this on your calculator, you would see that it's actually just a 2, and then we have x. So we actually have 2 to the power of x, 3 minus x smaller than or equal to 0. And so there is no mathematical way to solve this. You cannot go and multiply that in. It's just going to be weird. So instead, you need to see this as two parts. Here's the first part, and here's the second part. Okay? Now, when you multiply those two parts together, you want the answer to be this. Now, what this means is smaller or equal to 0. Now, when something is smaller than 0, it means it's negative. Okay, so they want this whole expression to be negative. So we're going to start by analyzing this one. Now, what we said earlier was that this kind of expression is always going to be positive for any x value. No matter what x value you go and plug in here, whether you plug in a negative x value, a positive x value, this expression is always going to be positive. It won't even be 0, so you wouldn't even put a line over there. You would just say that it's positive, okay? So if that expression is always positive, then what must this part be, this part here, so that when you multiply these two expressions, it's a negative, because that's what smaller than 0 means. So if this part's always positive, then this part would have to be negative. So then we can say, therefore, 3 minus, or I don't know why I'm doing this on the side. Let's actually do it right here. Then we can say, therefore, this expression would have to be smaller than or equal to 0. And then if you had to go solve this, you can solve this by taking the x to the other side, and there we have it. So that is the answer. X must be bigger than or equal to 3. Now, just over here quickly, some learners might have done this in a slightly different way. Some learners would have taken the 3 over instead, so you would have ended up with that. Then, if you had to get x by itself here, you would have to divide by a negative. And when you have an inequality and you divide with a negative, you have to flip the sign. So now we get an answer that looks like this. But if you look carefully, it's exactly the same as that. Here it says that x is bigger than or equal to 3. Here it says x is bigger than or equal to 3. It's just written the other way around. And so once again, guys, this part here, you don't really go and solve it. You just use that part to help you to understand, is that part positive or negative? And then from that, you can work out what this part has to be, so that when you multiply these two expressions, it gives us whatever they want over here, either a negative or a positive. Here we have a square root equation. Step 1, get the square root alone. So here we have the square root. So we're going to take that 2x over to the other side. Step 2, square both sides like that and like that. Now this 2 cancels out the square root. And so all that you are left with is whatever's inside the square root. And then over here, you're going to get, this is the same as negative 2x multiplied by negative 2x. So it actually becomes a positive 4x squared. Now, this is easy. Now you're just solving a quadratic equation. So I'm going to take everything to the right. You could have gone to the left, doesn't matter. And then you could try factorize here, but I think, what do we want to do? You see, I would just go and say, let's just use the quadratic formula. So let's write out the formula. But you can try factorize. Now, to use the quadratic formula, you must plug in the values. So we know that this is always a, this is always b, and this is always c. So just go plug that in. 7 squared minus 4. Now a is 4, c is minus 2, and then a is 4 again. Okay, that's all that you need to show them. Now you can go get your two answers. You should get x as a quarter, or x equals negative 2. So this shows me that this could have actually factorized quite easily. You would have gotten 4x minus 1 and x plus 2. So I just want to double check, 4x squared plus 8x minus, yep, that is how you would have factorized that, for those of you that are interested. Now, whenever we have a square root equation, when you get your final answer here, always do a check. So we're going to go do a check now. The way that you do it is you just go plug in, let's start with our first value, and you just go plug it into the left side of the equation and the right side of the equation. So here's the left side of the equation, and here's the right side. So we see that the right side is just equal to 0. So on the left, you would get 2 minus 7 times 1 over 4 plus 2 times 1 over 4. And let's see what that gives us. Okay, that gives us 1, and so this does not equal the right-hand side. And so we're going to put a little line through this one because that one is causing a bit of a problem. Left-hand side has to be the same as the right-hand side. Now we're going to go check the other one. So now we're going to go check the x equals to -2. And so if we do that, we'll go plug it into the left-hand side and then the right-hand side. But once again, we know that the right-hand side is 0. And so this is going to become square root of 2 minus 7 times -2 plus 2 times -2. And if we had to go type this in, we get 0. Fantastic. So left-hand side and right-hand side are equal, and so this is a valid answer, but this one is not valid. With a question like this, well, all that I would try to do is at the top, oh, first of all, I see that these are 2's, but that's a 4. Okay, so step 1, I would go change this. So I would break all of the numbers down to their prime numbers. So I know that the number 2 cannot be broken down any further. You can only write it as 2 times 1, but you haven't really broken it down. But I know that the number 4 can still be broken down into 2 times 2. So I'm going to write this as 2 to the 4025 plus 2 to the 4023, and then that's all over. Now I'm going to change that 4 into 2 to the power of 2, like that. Now in the next step, I need to multiply these two together. Okay, so that's going to be 4022. Okay, now this step, what you want to do is you want to factorize. So if you look at, let's say I had, for example, x to the 11 plus x to the 3, what would you take out as a common factor over there? Well, you would take out an x and then to the power of 3, right? So we're going to take out a 2, and then you're going to take the smallest of those. That's going to be 4023. And now what are you going to have left? Well, if we have x to the 2010 as an example, plus x to the 2003, and if you take out x to the 2003, then what would we have left over here? Well, you would still have 7 left over there, and then there's nothing left over here, so you would just say plus 1. So here we're going to say 2, and now because we took out 4023, but we have a 4025 here, there's still going to be 2 left over there, and then here we're just going to be left with a 1. Now at the bottom, we can't do anything, so we just leave it as is. What some learners now do incorrectly is they think that they can cancel these 2's out. Let me show you an example. If we have x to the 12 over x to the 3, what does that become? It stays x, and then what do you do with these numbers? You subtract them. So we're going to do the exact same scenario now. You're not going to cancel the 2's, just like we didn't cancel these x's out. And so it's going to stay a 2, and then you're going to subtract those 2. So that'll actually end up just giving you a 1. And then you're going to be left with 2 to the 2 plus 1. And so this ends up becoming 2 times by 5, which is 10. Step 1 with a simultaneous equation is choose the easiest looking equation, which would be this one, and get x or y by itself. Getting y by itself is going to be the easiest, and so you're just going to get 2x minus 1. You're now going to take that, and you're just going to substitute it in to the places of y. If you want, we can first go and multiply this out and simplify it. It doesn't really matter, but I think that'll actually be easier to work with. So let's first go and multiply that together. So if you had to multiply this together, you're going to get 3x squared plus 3xy minus xy minus y squared. And then I'm just going to simplify a little bit. So 3x squared. This will become 2xy. Now we can go plug this into the place of all the y's. So it's just going to go like that. And then here we have a minus, and then we have a y squared. So it's going to become 2x minus 1. Okay, now you're just going to go multiply everything together, neaten everything up, and then we're just going to solve for x. Now here's an area where learners make mistakes. You don't want to put this negative inside. We can't because there's a 2 there, an exponent of 2. So instead you're going to double bracket. Okay, And then let's go, I'm just going to quickly put these together so long. So it's going to become 7x squared. Okay, now I'm going to leave this minus here, and then I'm going to open up a bracket, and I'm going to multiply these two expressions together. So it would give us 4x squared minus 2x plus 1. And so we end up with 4x squared minus 2x minus 4x squared plus 2x minus 1. Okay, now it's just a case of simplifying. So 7 minus 4 is 3. Minus 2 plus 2 plus 2 will just give you 2. And then minus 1. Okay, here you have options. You can try to factorize if you're feeling brave, or you can use the quadratic formula. I think I'm just going to go straight to the quadratic formula, which is this one here. And so remember, this will be A, this will be B, this will be C. And so it's going to become minus 2, and then 2 squared minus 4. Now A is 3, C is minus 1, and then A again is 3. Okay, the rest you can do on your calculator now. X will then be a third, or X is minus 1. Okay, but now we need to solve for X and Y. So then what you do is you just come back to this expression here. And so we'll just go plug in our first X value, which was a third. And so Y would end up being negative a third. And then you go find your second Y answer by plugging in this X value now. And so that would end up being negative 3. Two integers have a sum of m and a product of n. Oh, don't we just love these questions? Determine an expression for the sum of the squares of the two integers in terms of n and m. Nah, let's leave this one. Okay, no, I'm joking. Two integers have, okay, so let's call the two integers x and y. Okay, so let's just call it x and y. Now, two integers have a sum of m. What does sum mean? Sum means when you add. So if you add them together, you're going to get m. And then if you product, or if you multiply them, it's going to give you n. Okay, that's already looking a little bit better. Determine an expression for the sum of the squares of the two integers. So the sum of the squares. So what they mean is, what is x squared plus y squared? Now, how are we going to take this information and somehow come up with x squares and y squares? Well, one thing we can do is we can take this expression x plus y equals m, which we have. Now, in mathematics, we are allowed to square both sides, as long as you do it to both sides. Then, if you had to go and expand this side, you would end up with x plus y equals to m squared. And then if you had to go multiply out, you'd get x squared plus xy plus xy plus y squared. Now I'm starting to see the x squared plus y squared. And so let's get that by itself. And then we take this to the other side. So it'll be m squared minus xy minus xy. And so we end up with x squared plus y squared equals to m squared minus, now xy is n, and another one, DJ Khaled. And so minus n would be minus 2n, and there we have solved. Consider the arithmetic sequence, and then they give us the first three terms. Determine the value of x. So we know that when something is arithmetic, then we know that we can always use this formula. T2 minus T1 is equal to T3 minus T2. We've seen that many times. So if we go for in T2, and guys, for those of you that don't understand where this even comes from, it's actually very simple. Check this out. If I show you a basic arithmetic pattern, if I take term 2 and I minus it from, and I minus term 1, I end up with 3. And if I take term 3 and I minus term 2, I also get 3. And so we can see then that term 2 minus term 1 is the same as term 3 minus term 2. We're simply realizing that there's a common difference each time. That's all that this formula is actually saying. So term 2 is going to be 2x plus 1. Now when you minus, you must use a bracket. x minus 3. And then we're going to say 4x minus 1 minus 2x plus 1. And so we end up with 2x plus 1 minus x plus 3 equals to 4x minus 1 minus 2x minus 1. And so now we can just simplify. So on the left, we just get x plus 4. On the right, we get 2x minus 2. And then you can solve this however you feel comfortable, but you should eventually end up with x equals to 6. This question here says, calculate the value of the 7th term. So because they just want the term, we can just use the TN formula. And because it's arithmetic, that's our formula over there. Remember that A is term 1, D is the difference. Okay, so we don't know what the difference is just yet. So to find the difference, we're going to have to go see what term 1 and 2 will be. So term 1 is going to be x minus 3, which is going to be 6 minus 3, because x is 6, and that'll give us 3. Let's rather do it like this. Okay, now term 2 is going to be 2x plus 1, which is going to be 2 times 6 plus 1, which is 13. So if you had to work out the common difference, you would just say term 2 minus term 1, and that would give you 10. And so we can now go work out what term 7 is, because we now have A, which is term 1, which is 3. N is your term, which is 7, and then the common difference each time is 10. And so term 7 would end up being 63. Consider the quadratic sequence 2, 7, 16, 29. Now, guys, you're going to get some amazing marks here because that's an easy question. Here they're asking you to find the nth term. You should all get full marks there. And then the rest might get a little bit interesting, but you should definitely be getting these two. Okay, so it says consider the quadratic sequence and determine the 5th term. So if we have 2, 7, 16, 29, then if we just go work this out, the difference there is 5, the difference there is 9, the difference there is 13. Then the difference there is 4, and the difference there is 4. So with a quadratic, we know that these remain constant. So if we then wanted to find the next term, we could just add on another 4 here. So this would be 17, and then 29 plus 17 would give us 46. For some reason on the memo, they have it as 45. Anyways, okay, so this one says, determine the nth term of the quadratic sequence. So here's where we simply just go use the formula. So 2a equals to that, 3a plus b is equal to that, and then a plus b plus c is equal to that. Because we know that the formula for a quadratic is an squared plus bn and plus c. So we are going to use these three formulas to find a, b, and c. So we always start at the bottom, and so that means that if 2a is equal to 4, so 2a is equal to 4, then a must be 2. Then we go up to this next one, so 3a plus b equals to 5, and so 3 times 2 plus b is equal to 5, and so that's going to be 6 plus b equals to 5, and so b would be negative 1. And then you use this formula to find c. So we know then that a plus b plus c must be equal to 2. And so a is 2, b is minus 1, so let's just say minus 1. And then c is what we're trying to find, Kevin. And so we get 1 plus c equals to 2, and so c is 1. Okay, so then it looks like our formula will be a, which is 2, b, which is negative 1, so you can just say negative n if you want, and then plus 1. And then what I always tell learners to do is to make sure that that is correct. The way that you do it is you just choose one of these numbers over here. I'm going to choose this one, which is term number 4, and I'm going to go work out term 4 here by plugging in a 4 in the place of n, and I want to see and make sure that I do get 29, because then I know my formula is correct. And so I end up with 29. So that is correct. This question, show that the sum of the first differences can be given by this. So if you look at your first differences, which are these ones here, then that just becomes a normal arithmetic pattern. Think about it. 5, 9, 13, 17. That's just a normal grade 12 arithmetic pattern where we've learned how to find the sum by just using the sum formula, which is this one over here. And so we're just going to go and work out what Sn is in terms of n. So we're just going to leave it as n. So we already know that A is term 1 over here. Now here's where learners are going to get confused. This A is not the same as this A. We know that in this formula, A is term number 1, which is 5. Okay? D is the common difference. We can see that the common difference is 4, and we even saw it over there. So we just say plus 4. Okay, now we're just going to go simplify. So 2 times 5 is 10. And then I'm going to multiply this 4 into this bracket. So it'll become plus 4n minus 4. And so Sn is going to end up being n over 2 times by, now 10 minus 4 is 6. Okay, and now we are just going to go and multiply in. So if you multiply these two together, you end up with 6n over 2. And then if you multiply these two together, you end up with 4n squared over 2. And then if you simplify, we know that 6 divided by 2 is 3, 4 divided by 2 is 2, and so we end up with what they wanted. Now with this next one, it says that if the sum of the first 40 differences in question, blah, 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 guys, we don't even need to go do any of that. It just says which term in the quadratic sequence has a value of 3,322. We've already worked out the formula. Let's ignore their little fancy, and let's just go do it this way. So 3322, they want to know which term in this quadratic sequence has a value of 3322. So we're going to fill in 3322 over there, and we're just going to go 2n squared minus n plus 1, and now we solve. Bob's your auntie. So if you had to take that over, it would become negative 3321. And now you can just solve using the quadratic formula. So we know that the quadratic formula n equals minus b plus minus b squared minus 4ac over 2a. And so this would be a, minus 1 would be b, and then this would be c. And so you would end up with b as minus 1, a is 2, and then c minus 3321. Okay, let me just make a bit more space there. Okay, and so you end up with 41 or negative 40.5. But you can't have a n value that is negative, first of all, and it also can't have a decimal. It has to be a like a normal counting number, because n tells you how many terms. So you can have term 1, term 2, term 3, term 4. You can't have term negative 3, and you also can't have term 7,4 as an example. So this would be the answer, and there we go. Determine the number of terms in the following geometric sequence. Okay, so we know it's geometric. They've told us already, so we can just use the Tn formula. And we know that the last term has a value of that, so we'll fill that in as our last term. And then A is always term 1. Now R is your ratio. So for example, if we had a pattern that was like 2, 10, 50, then you would see that your R value is multiplying by 5 every time. So R, you can always find it by taking the second term divided by the first term. Like in this example, you would have gotten 5. So in this example, you're going to say term 2 divided by term 1. And so it's going to be square root 3 over 2 divide with 1 over 2. So you can type it like that on the calculator, and you will end up with square root 3. So R is square root 3. So we're going to go square root 3 and then to the power of n minus 1. Okay, so This part here is stuck together, so you cannot separate that from each other. But this half, we can take that to the left. So we can divide this by a half. Okay? And then what you end up with is just this on the right. And so on the left, you're going to end up with 81 square root 3. And on the right, you're going to end up with square root 3 to the n minus 1. Now there's two ways to do this next part. You could use logs. So if you do decide to use logs, you would just say that n minus 1 is going to be the log of square root 3 and then 81 square root 3 over there. That would work. But the other way is to realize that if you take this number and you say shift fact, it's 3 to the power of 4. We know that any number or anything inside a square root can be rewritten as to the power of a half. And then we can also write this one to the half, and then we've got n minus 1. Now, if we use exponent rules, be careful here. You're not going to turn this into a 9. Instead, if you have a4 times a3, that becomes a7. So you add the exponents, but you leave it as a 3. 4 plus a half is 9 over 2. And then here you're going to use exponent rules where you have to say, if you had like a to the 4 to the power of 3, you multiply now. So it's going to become 3 to the half n minus a half. Now I've got 3's on both sides, so I can ignore that. And so I now just end up with that. There's different ways you could solve this. One of them is to take this to the left. And so that would eventually give you a 5. Then you can divide both sides by a half, and you should eventually end up with n equals to 10. So there are 10 terms. This one looks fun. So let's have a look. Oh, mem. Yo. Ah. Funyas. Oh, shit. Okay, it actually doesn't look bad because they want us to solve for p, and p is part of this expression, but they tell us that this expression is equal to this. And this we will easily be able to go and calculate because we have everything that we need. So let's begin there. So we're going to start with that. Minus 27 minus 2 over 3 m. So first step, we're going to go find term 1, 2, and 3 over here. So we can see if it's arithmetic or geometric. It's going to be geometric because we've got this weird exponent vibe going on. But let's just go do this anyways. So term 1, to find term 1, you always start off with whatever number this is. It won't always be a 1, but in this case it is. So you're going to go plug that in over there. And that'll end up giving us 18. So term 1 is 18 over here. Now term 2, you're just going to increase this number by 1. So that's going to become a 2. And so that'll be minus 12. And then lastly, term 3. So you're just going to go plug in a 3 now. And that'll be 8. So many learners think, oh, so Kevin, are you saying that because it's term 1, I must put a 1, and because it's term 2, I must put a 2, and because it's term 3, I must put a 3? That's not correct. The only reason it looks that way is because they put a 1 over here, but they could have put a minus 1 over there. Then your term 1 would have had a minus 1 here, your term 2 would have had a 0, and this would have been a 1. So it's all got to do with what they start off with over here. It's just a coincidence that these two are being the same each time. Okay, so look out for that. So here we have the first 3 terms. So now we need to go and make sure that it is actually geometric. So we know that if you have something geometric like this, where you, for example, are multiplying by 2 every time, then it means that if you take 10 divided by 5, you get 2. And if you say 20 divided by 10, you also get 2. So if we can show that the ratio is remaining constant, then we can say it is geometric. So then what we'll do is we'll start off by saying minus 12 divided by 18, and that'll give you negative 2 over 3. Then, then we're going to go do it for these two. So we're going to say 8 divided by minus 12, and that would give you negative 2 over 3 as well. So then we can confidently say that this is geometric. So we can now go work out what this actually means or what it equals, because we should know that this over here, when you're using a sigma, it means sum of. So we know that to calculate the sum of a geometric, we could use this formula over here. You can also use it the other way, where the r is first at the top and the bottom. But we want to know, what is the sum of... Now, how many terms do we have? Some learners are just going to say, oh, Kevin, it's 7 because there's a 7 over there. Not correct. It is 7, but it's not for that reason. So I'm going to explain it the proper way so that if they ever change this number in an exam, it doesn't catch you out. So what does Kevin always say? The number of terms, so number of terms, which is your n in the formula, is always equal to the top number minus the bottom number plus 1. So it's the top number minus the bottom number plus 1. So in this scenario, because this is a 1, these two are going to cancel, and so you are going to end up with 7 terms. But that then doesn't mean that every time you do a sigma question that you always take that as your number of terms. It's only true when this is a 1, and in many exams this won't be a 1, so please be careful for that. So we now know that there are 7 terms, and term 1 is 18. The ratio that we found was negative 2 over 3. So you're going to put that in a bracket to the power of 7 like that. And then r is negative 2 over 3 over there. Now you can just go type this all in on your calculator. It's a clump numbers, my bro. So 1 minus 2 over 3. What? Dump valve. Yo. Random, eh? So if we go work out the first 7 terms, we should end up with 926 over 81. Don't round off because this is not our final answer at all. So now what we can say is that this expression is equal to this, which is equal to that. So we can then just say, there we go. So we've solved one extra piece of the puzzle. Okay, now we know that this is just going to be a sum to infinity. So sum to infinity is always a over 1 minus r. And so, but now be careful, this a and this r are for this part. So that has its own a and its own r. It's not the same as the a and the r that we found when we were looking at this part. They're two different parts, okay? So we need to go find our a and our r over here now. So for that part, we need to go find the first 3 terms once again. So term 1, term 2, term 3. And technically you only have to find the first 2 terms because we know that it's geometric, because we can only do infinity with geometric patterns. So we've got 9p to the k, and that's that. And that's that. Okay, so term 1, you always start off with whatever number's at the bottom here. And so that's going to be a 0. And so anything to the power of 0 is a 1. So this is just going to become 9 times 1, which is just going to be 9. Then to find term 2, you just increase this number by 1. And so it's going to be 9p to the 1, which is just 9p. We don't need to go find term 3 because we know that it's geometric already. So now if you wanted to find the ratio, you would take term 2 divided by term 1, and that would be 9p divided by 9, which is just p. Okay, so we now have the ratio, and we have a, which is term 1, and so we're good to go. Bob's your auntie. And so it's going to be a, which is 9 over 1 minus r, which is p. And so that is what this expression now is. So we can now say 9 over 1 minus p is equal to 926 over 81. Now in mathematics, whenever you have a fraction equal to another fraction, what do? Cross multiply. And so this is going to go there, and then this is going to go there. And so we end up with 9 times 81 equals to 926 bracket 1 minus p. And now we just solve. And so 729 equals to 926 minus 926p. And so now if we take the 926p to the left and we take the 729 to the right, we'll end up with 926p is equal to 197. Divide both sides by 926 and we end up with 0,21. Here are all the questions that we will be doing in this question, but I'm going to split them up so we have a bit more space. So let's get started. Okay, so let's put me over there. Okay, so it says that the graphs of f and g are sketched below. Then there's a line h is an axis of symmetry. So let's just quickly make sense of everything so far. So they tell us that we have a graph f. Okay, so f is a parabola. So that's, whoa, okay, that's this one. Whoa, what's going on here? Okay, there we go. And then we've got a graph of g, which is a hyperbola. Let's do it in a different color. Let's do it in this. So that's a hyperbola. And there. And then they've told us that the line h is an axis of symmetry of g. So we know that when you have a hyperbola, maybe you have a hyperbola like there and there, then you've got these lines that go through the asymptotes, which is a line that goes this way, and then we have a line that goes that way. And those are your symmetry lines of a hyperbola. So they've told us that h is a line of symmetry. So there it is over there. And we can see that it's going directly through where the asymptotes intersect. Okay, so that's what we have. Hey guys, so I realized that I forgot about question 4.1. Well, I didn't record it. So all you need to know for 4.1, it says write down the coordinates of C. So all I did was I took the equation of H and then I just went and found its y-intercept. So I just made x 0 and I ended up getting 3 as the y value. So I need to quickly remind you about something that we learned in earlier grades. When you have a hyperbola, and let's say it's over here, and it's over here, and we have it there and there, okay? Now, when you have your symmetry line that goes through this point, you've got one symmetry line that goes that way, and you've got another one that goes that way. But let's ignore that one. In grade 10, we already started learning that the place where the symmetry line, which is the green one, intersects the graph, that point there and that point there, that was always, there was always a special way to work out those coordinates. And those 2 points, remember you would use like a square root of this and a square root of that. We don't need to go into that now. That's not what this question is focusing on. But the important thing to understand as well is that this point over here is exactly halfway between those 2 points. And so we know the coordinates of C from this question, and we know the coordinates of A because they've given that to us. So then the coordinates of B is the midpoint of those 2 points. Okay, because you can see we've got our symmetry line, which is this one. They told us it's a symmetry line. And we can see that that is where it intersects the hyperbola, and that is where it intersects the hyperbola. So we've got the exact scenario happening as we see over here. Okay. And so to find the coordinates of B, we're going to use the midpoint formula. So that's going to be x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. I'm just going to use this as my point number 2, and I'll use this as my point number 1. You can do it however you like. And so we're going to say, we know that the coordinates here are 0 and 3. So the x value at point number 1 is a 0. The x value at point number 2 is a 4. And then the y values like that. And so if you had to go work this out, you would eventually end up with 2 and 1. And that's exactly what they asked us to find there. Okay, now we're moving on to this next one. Guys, just remember that these are not the only questions. We also have 4.5, 6, and 7 on the next slide. So this question for 4 marks says determine the values of A, R, and T. A, R, and T. Extremely easy because now we have the coordinates of B. So there's a lot of information that we can take just from that. If you have, here's some examples. If you have a hyperbola, and let's say your asymptotes are here at x equals to 1, this is just an example, and y equals to 2, then we know the hyperbola equation goes like this. Now, this part here tells you whether your graph has moved right or left. So if you have an asymptote that is over here, then your graph has moved one place to the right. And so at the bottom here, you would say x minus 1. And then this part here means that your graph has moved up by 2, so you would say plus 2. Okay? Here's another example. If you have a scenario like this, and maybe like this, then if this is y equals to 1 and this is x equals minus 2, then in your scenario, or in that scenario, this graph has moved 2 places to the left now, so you would say x plus 2. Plus means left, minus means right, and then it's moved 1 place up, and so you would say plus 1. So the horizontal asymptote, which is this one, that is easy. If it's up, you say plus. If it's down, you say minus. But the vertical asymptote, the one that moves left and right, that's the opposite. If it's gone left, you say plus. If it's gone right, you say minus. So by having B's coordinates is really, really nice, because what that tells us now is that if I have a dotted line here, and if I have a dotted line here, and if I know the coordinates of that is 2 and 1, then it tells me that the x value there is 2. So it means that this line has an x value of 2. So that's x equals to 2. And it tells me that this line, the y values on that line are equal to 1. So we say y equals to 1. So we know these asymptotes now simply because we have the coordinates of B. Right? Let me explain that. Maybe there's some learners that don't understand what I mean by that. So let me draw it a little bit nicer for you guys, or a little bit better. So if I know that this coordinate is 2 and 1, then if I look at any place along this line, if I go down or if I go up, the x value will stay 2 because it's a vertical line, so the x value doesn't change. So everywhere on this line, the x value is always going to be a 2. And now if I look at the y value of 1, if I go to the left or if I go to the right, the y value is going to stay a 1 because we're not going up and down, we're only going left and right. So everywhere on this line, the y value is a 1. And that's why we call that the y equals to 1 line. So if we now know that we've got that and we've got that, well, then we can go full in this part of the equation and this part of the equation. So we know that at the bottom here, it's going to say, well, let's go write this out as G equals to A. Now, because it's gone 2 places to the right, we can see it's moved 2 places to the right. We're going to say X minus 2 at the bottom here, and then plus 1 over here. So that means that the R value is minus 2. The T value is 1. And then the last thing we need to go and find now is A. But that's easy, because if we have the equation A over x minus 2 plus 1, the only unknown letter is A. So all that you do is you find any point on the graph. So any point on this graph, that graph there, or that part over there. So I'm just going to use that part over there. I know that I've got this coordinate 4 and minus 1. So I plug in minus 1 as the y, 4 as the x, and then I end up with minus 1 equals to a over, now 4 minus 2 is 2. Okay, now you want to solve. So the way you'll solve this is take this plus 1 to the other side, so it will become minus 2. Now you could think of this as minus 2 over 1, and then in mathematics, whenever you have a fraction equal to another fraction, what do? Cross multiply. And so that's just going to become minus 4 after you multiply these two together, and then a after you multiply those two together. And so you end up with something like that. And there we have it. So a is minus 4. Okay, now this question over here. Now remember, guys, we do still have more questions coming up on the next slide. Okay, we've got 4.5, 6, and 7. This question says, determine the equations of the asymptotes of the graph of J if J is equal to this. Okay, very straightforward question. So at the moment, the graph of G is, remember, that is our hyperbola. So this is currently the graph of G, right? There we go, and there we go. And G has asymptotes. It currently has asymptotes. Here's an asymptote, and then it's got the other asymptote over here. Now remember, the asymptote equations are x equals to 2, because remember, we know that this b value has coordinates of 2 and 1. So it means that the x value there is 2. So if you go up, the x value doesn't change. X only changes if you go left or right. So the x value anywhere on this line is going to be a 2. And if you go anywhere this way, the x value will always be 2. So in mathematics, we then call that line the x equals to 2 line. And anywhere on this line over here, the y value is always 1. Because from this coordinate here, we know that this y value is equal to 1. And if you go to the right, or if you go to the left, y values don't change because they only change when you go up and down. So then what we can say is that anywhere on this line, the y value is 1, and so we call that the y equals to 1 line. Okay, so those are the current asymptote equations for this graph. They then say in this equation that, okay, so now we have a graph of J, and they say that J is equal to this and this. So guys, when you look at this over here, you need to know exactly what that means. So what it means is the following. The first part I want you to look at is the part where they're changing the x values. So whenever you have a x plus 3, it means that you are moving 3 places to the left. And then whenever you have a minus 1, it means that you are moving 1 place down. So what this means mathematically is that J is the graph of G after G is moved 3 places left. Because remember, whenever you have a plus, that always means left. And then 1 place down. Okay, here's another example. Let's say we said W is equal to R x minus 3 minus 4. Then what this would be saying mathematically is that W is the graph of R after you have moved R 3 places to the right and 4 places down. Okay, so anytime they're changing the x's, that means left and right, and then anything at the end over here, that is changing the y values, so up and down. Okay, so then if you take the current graph of G, which is this hyperbola that I showed you now, sorry, it's just the hyperbola part, that part, and that part. If you look at its asymptotes, which are these ones and these ones, what are those equations going to become after you do this? So if you move them 3 places left, where is this vertical line going to go? Where is the x value of that going to become? Or what is it going to become? So here it's an x value of 2. And then if you move it 3 places to the left, it would end up at x equals to minus 1. So that's our first answer. It would end up over here at x equals to minus 1. Okay? And then what would happen to this over here after you move 1 place down? Well, that would literally land up on the x-axis. And on the x-axis, we call it the y equals to 0 equation. And so there's your 2 answers. Question 4.5 says, show that the equation of f is given by this. So they pretty much want us to go find the equation of f, which is a parabola. Now, normally there are 2 ways to find the equation of a parabola. either you're going to use the x-intercept method, where you would go and you would typically use an equation like this, okay? Or you can use the turning point method, which is where you'll typically see an equation like that. Now you'll notice that they've given us an equation with a plus over there. So you are more than welcome to put a plus over here, or you can leave it as a negative. It doesn't affect the final answer. As long as you understand what you're doing, it doesn't matter. So you can choose there what you want to do, okay? And as I said, some of you might have seen all of my other previous videos and I normally use a minus. We honestly can. But then some of you are going to be like, yeah, but Kevin, here they have a plus. Guys, it doesn't matter. Different textbooks, different exams, different videos are all going to show different things. That part's not that important. It doesn't affect the final answer at all. So you can decide over here, do you want to use a minus? Do you want to use a plus? It really, really doesn't make a difference in this scenario. So I'll just leave it as what I typically have it as. Oh, I don't know. You see, I don't know. I don't want to confuse learners. I don't want them to be like, yeah, but sir, it says plus. Like, I don't know. And then other learners are going to be like, yeah, but sir, don't you normally put a minus there? So guys, either way is going to work, okay? Now, the next thing is, notice that they've given us the a value. They've given us that, so we're going to use a half over there. Okay, but now normally you would have to decide, do I want to use the x-intercept method or do I use the turning point method based on the information that is given? So if we look carefully, there is no x-intercept information. However, they have given us a little bit more info around the turning point, and so that one would definitely be the better equation to use. And so all we do now is you need to remember that this part over here tells us whether the graph has moved left or right. And so here we can see that the turning point has been moved left. That's why it is at x equals to minus 2. So what does this bracket need to say? Does this bracket need to say x minus 2, or should that bracket say x plus 2? Well done if you know that it must say x plus 2. And so we are going to go and fill in, oh no, we have the a as a half, and then we're going to say x plus 2. Okay, and I'll just quickly show you one or two other examples. If you have a parabola that is over there, for example, at 3 and minus 2, then your turning point equation would say x minus 3, because it's now to the right, and you would say minus 2 over here. Then if you had another scenario where you had a parabola that maybe looked something like, so maybe this coordinate was minus 2 and minus 1, then your equation would then say x plus 2 minus 1. So this part of the formula is always a little bit different to what you would expect. If the turning point is at x equals to minus 2, then we say x plus 2. And if the turning point is at x equals to 3, then we say x minus 3. Okay, that's something we've spoken about a lot, and that's exactly what happened over here. So because this is x minus 2, I wrote it as x plus 2. Okay, now for this part here, we don't know what this is, so we could just say plus w. Now some of you might say, Kevin, but because it's down here, shouldn't we say minus w? You can, but we can rather just leave it as plus w, and then when we go and calculate the w value, it'll just end up being a negative. And that makes sense because this should be a negative, for example. Okay? So you can just leave it as a plus w, like that. And so now what we would typically go and do is we would then go fill in another point on that graph. So we do have another point on the graph here at 2 and 1. So because that point is on the parabola as well. So we can fill in the y value of 1. We can fill in the x value of 2. And so now we just end up going, this you can just type in your calculator. That's just a number. That's going to give you 8 eventually. And then if you had to go solve, you're going to end up with minus 7. Okay, so now what we have is y equals to a half x plus 2 squared minus 7. So to go from here to here, we just need to go and simplify now. But there's two areas where learners make mistakes. The first one is that when they try to multiply this out, they think that they can just put the half inside. But you can't just put the half inside because there is a 2 over there. Okay? The next thing learners get confused is they think, okay, well, fine, I'll put the 2 inside. So does it just become x squared plus 4? No, you need to make 2 brackets. So you're going to end up getting y equals to a half, x plus 2, and then another x plus 2, like that. So now what I'm going to go and do is I'm going to go and leave the half alone, and then I'm going to multiply those 2 brackets together. So that's going to end up becoming x squared plus 2x, which is going to be 4x plus 4, and then this is going to be minus 7. Then you're going to multiply the half in, so you're going to end up with a half x squared plus 2x plus 2 minus 7. And then if you had to go and simplify, you end up with negative 5 like that, and that is exactly what they wanted. Okay, so let's go to 4.6. It says that if f is equal to k, determine the values of k so that this equation would have 2 negative roots. Right, so the first thing you need to understand is that this question cannot be solved with nature of roots. Okay, the reason is the following. When you look at the nature of roots, you always go look at the b squared minus 4ac. And if you had to go and look at the different options, we know that if you get a negative value, we call that non-real. If you get any value that is 0 or anything positive, we call that real. And inside of that, we've got 3 different categories. If it's a 0, we call it equal roots. If it's a perfect square, like 25, 36, 49, we call it rational. Let's write that a bit better. We call that rational. And then if you get anything else, like 17, 15, 124, any number that is not a perfect square, then we call that irrational. So the only things that this b squared minus 4ac can ever tell you is whether the roots are non-real, equal, rational, or irrational. They can't tell you whether the roots are going to be positive or whether the roots are going to be negative. They only tell you those 4 different things. So they didn't say here non-real, equal, rational, or irrational. They didn't say any of that. So nature of roots is not going to help us at all. So what we actually need to just do is the following. If you say f of x equals to k, you must understand that this is a y value. Now, if you say, for example, f of x equals to 3, or let's say 5, then you are saying that the y value on that graph is 5. So where would y equal to 5? Well, we know that any line y equals to 5, it's a horizontal line. So if you had to go on the y-axis and you go to the y value of 5, it would be somewhere like here, because we already know that this y value is 3, because that is I think we worked that out in the previous, we worked that out over here, remember? So we know that that's already a y value of 3. So if we had to go at a y value of 5, it would be a little bit higher up, maybe over there. But now where would the y value of 5 be on the parabola? Well, it would be over here, and it would be over here. So on those 2 points, the y value of the parabola would be 5. Okay? But what would the x values be there? Well, this x value, would it be negative or positive? That would be negative. And what about this x value? That would be positive. Okay, so what we are trying to find is what y values can we find, or where are the y values where we will have 2 negative x values? Because when y is 5, this x value is negative and this x value is positive, so it's not that. Okay, so then let's just try a whole bunch of different y values, like y equals to 6, y equals to 8, y equals to, let's just see. So let's just go draw a whole bunch of horizontal lines, because those are y values, right? This might be like y equals to 6, this might be y equals to 8. And let's go look at y equals to minus 4, which would be like here. And let's go look at the x values for each of those. So if we look at y equals to 6, look at the x values. There's a negative x value, and there's a positive x value. Okay, so that's not what we want. If we had to look at y equals to 8, that x value is negative, that x value is positive. So that's not what we want. Okay, so it's none of those. What about y equals to minus 4? Well, we know that this y value here is minus 5 because of the equation. There's the y-intercept. So at y equals to minus 4, it would be here. So if you had to go look at the x values, it would be a negative x value and a positive x value. So that's still not what we want. But now here's where the magic happens. If you had to look at any of the y values between these 2 points, so if you had to go draw a horizontal line there, maybe that would be y equals to minus 6. Then have a look at the x values. We've got one x value there, which would be negative, and we've got another x value there, which would also be negative. So this is what we are looking for. We wanted to know for which y values are the x values both negative. So if you had to look anywhere between the turning point and the y-intercept, all of those would be solutions. But as soon as you go above this point, so as soon as you go there, then all of a sudden the y value there is negative and the y value there is positive. So that's not what we want. So we want to be somewhere between the turning point and the y-intercept, because anywhere in that area you've got a negative x value and another negative x value, and that's what we want. So we are going to say then that k can be any number between minus 7 and minus 5. If you prefer interval notation, you would say from minus 7 to minus 5. Now, are we going to include the minus 7? No, because at minus 7 exactly, there's only one x value, and that x value is minus 2. But they said that they want 2 of them, not just one x value, 2 x values. So we won't include the minus 7. What about the minus 5? Well, at the minus 5, which is here, but it would also be here because minus 5 is in both of those places, a y value of minus 5. This x value here would be a negative, which is good, but this x value here would be 0. But they specifically said they want them to both be negative. So we can't include the minus 5 either. It'll be all the numbers between those two values. And so that would be our final answer. Okay, so moving on to this last one now. It says, determine the values of d such that this weird-looking expression is equal to this weird-looking expression will have one positive and one negative root. Okay, actually quite straightforward. Let me try to break it down for you. So can you see that this is actually the equation of f, but all that they've done is they've just changed the x to x plus d. Okay? And then can you see that this is actually just the equation of h, and all that they've done is they've changed all of the x's to x plus d. So you need to remember what that does to a graph. If I have an equation like r equals to 2x minus 3, and then all of a sudden I go 2x plus 7 minus 3, then what this does is it moves the graph 7 units left. Whenever you have a bracket and you're changing the x values of an equation, you are then moving the graph left and right. For this one specifically, it was left, but when they just put a letter D, we don't know whether they're going to go left or right. Now, some of you might be saying, yeah, but Kev, they've got a plus over here, so doesn't that mean left? Not necessarily, because we don't know whether D is going to be negative or positive. So D might end up being negative, and then this whole thing's negative. So we don't know whether we don't know whether these graphs are moving left and right. But all we can say that is the following. If you just forget about the x plus D for now, and you just keep it as x, then if I gave you this, and then I made it equal to this, can you then see that that is the equation of f being equal to the equation of h? So when you make two graphs equal to each other, you are finding the place where they intersect. So at the moment, those two places where these two graphs intersect would be, so it's the straight line and the parabola. So that's literally there and there, okay? Now, if you had to look at the x values at those places, here you would have a negative x value, okay? And then over here, you've got a positive x value. We know that the x value there is 2. So they want to know, how must we move these graphs left or right, both of them, moving them left or right, so that we will have one positive and one negative root. So at the moment, they already have one negative and one positive root. But that's not the only solution that there is. We could probably still move these graphs a little bit more left and a little bit more right, and we would still have one positive x value and one negative x value where they intersect. So can you imagine just taking the parabola and taking the straight line and just sticking them together? So just imagine that they are stuck together. Then I want you to take both of them together and imagine you had to move both of them together to the left. Now I want you to, as I said, remember that those two graphs, just imagine that they are stuck together. And now let's imagine that you move them, let's imagine you move both of the graphs a little bit to the left. Can you see that these points would go to the left and this point would also go to the left, okay? Because we're moving both the parabola and that straight line by the same amount to the left. So it won't affect the shape, we're just shifting it all to the left. Can you see that if you had to move it far enough to the left, this x value here would actually end up becoming a negative value? Can you see at the moment it's a positive value, it's a positive 2. But if you had to move it further and further and further to the left, eventually it would move on to it would have a negative x value. So that would be incorrect. They want to know what d values can we use. So how far left and right can we move the graph so that the places where they intersect are still going to have one positive and one negative root. So you can move it to the left, but you cannot move it too far. Otherwise, both of those x values where they intersect are going to be negative. So how far can we move it left before that becomes a problem? Well, can you see that it's going to be this value, this point here, that we need to be careful of? Because we know that if this point over here moves up to there, then the x value is going to be 0 over there. And then if you move it any further, it's then going to have a negative x value. So can you see that we cannot move it any more than 2 units to the left? Okay, so let's say here, cannot move any more or any further than 2 units to the left. Because, don't worry, this isn't the answer that you're going to write in the exam. I'm just making some notes for ourselves so that when we go write out the final answer, we can understand. Because if we move it more than 2 units, then this point over here is going to end up maybe going there, and then this point is going to end up being there. This point's not a problem. That one's always just going to stay negative if we keep moving it left. But it's this point over here that if you move it too far, it'll end up changing from a positive x value to a negative x value, and we don't want that. So we cannot move this point any more than 2 places. Okay, now we need to look at the other direction. What if we now move the graphs to the right? So if you had to take this entire system and move it to the right, this point will just end up being positive, 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 positive. So we don't need to worry about that one because it already is positive. So we don't need to worry about that one changing sign. But this one over here, we need to watch out for that one, because if you move it far enough, it can eventually go over this y-axis and it eventually will end up having a positive x value, and we don't want that because then this one is going to have an x value that's positive and this one's going to have an x value that's positive. But we said that we want one of them to be positive and one of them to be negative. So this point can actually only move up to the y-axis, and then it needs to stop. So the first thing we actually need to go and understand is what is the current x value at that point. We need to know that so that we can see how far we can still move this way, because we don't know what this x value is. So to find that x value, you're going to make the two original graphs equal, which we actually did over here, and then you would go and solve that equation, because that's how you find out where two graphs are equal. If you had to go and solve that, you should get one x value as 2, which is this one here. We already know that they are equal to each other at x equals to 2. But then the other x value that you should get is x equal minus 8. So that means the x value here is minus 8. So that means that we cannot move any further than 8 units to the right, because if we go more than 8 units, this point is going to end up becoming positive. And then you're going to have two positive x values. And they specifically said we want them to have one positive and one negative. Okay, so that's our other limitation. We cannot move any further than 8 units to the right. Okay, so now we're going to try to figure out how to actually give that as an answer for D. So if we had to move 2 places to the left, then that would say in brackets it would be a half x plus 2 squared plus 2x plus 2 minus 5 equals to minus x plus 2 squared plus 2 plus 3. So that is what it would look like if we had to take these two graphs and move them 2 places to the left, okay? And then if we instead move them 8 units to the right, then your equation would be, don't worry, we're not going to have to go and solve all of this. I'm just showing you something. Minus 8 plus 3. So those are the two extreme scenarios. Now we want to move in between that. And so can you see here that the D value is minus 8 and the D value here is 2. So we want the D value to be anywhere between that. So we can say that D must be bigger than minus 8 or smaller than 2. If you prefer interval notation, you must say between minus 8 and 2. So here are all the questions that we have for question 5, but I will be splitting them up onto individual pages just so we have a bit more room to work with. So let's begin. It says that the graph of f and k, so we've got a log graph and we've got a straight line. It looks so nice and simple. Hopefully it stays that way. A is a point on f and D is the x-intercept of both graphs. First question, write down the coordinates of D. Right, so what we can do is you can take your log graph, and you must understand that at D, the y value is 0, because it's an x-intercept. So you can make the y value of 0. Okay, now to eventually be able to solve for x, we're going to have to reverse this whole log. So we're going to have to convert it to an exponential. So all that I've been telling learners to do recently is to understand the following. This number down here at the bottom, we call that a base. Okay, but now when you write something in exponential format, the number at the bottom is also called the base. So all I want you to remember is the following. When you switch from log to exponential or vice versa, the base stays the base. So what it means is that here we currently know that the b is the base. So when you switch this to exponential form, the b is just going to switch places, or it's the b is instead of having the b with the x, it's now going to be with the 0. So you're going to end up with b to the 0 like that. But notice that the b is still in the base position in both exponential form and in the log form. And that is what I'm saying. When you switch from log to exponential or exponential to log, the base stays the base. All that happens is that these two switch. Okay, so the b was with the x, now the b is with the 0. Now what's lovely is that anything to the power of 0 is 1, and so x over here would be 1, and we know that the y value was 0. this question over here says determine the value of b. So now we can go and take the equation of that log, so log bx, and we can simply go plug any point on that line. So let's plug in this one. Don't use this one because we've already used that. It's not going to give you any new information. And so if we go plug in y as 1, b is the unknown, x is a quarter. Okay, so here's another scenario where you're going to have to switch this to log. So you notice that the b is the base, and it's currently with the 1/4. All you're going to do now is keep it as the base, but instead write it with the 1, and then you'll just have the 1/4 by itself. So notice that the b is in the base position for the log. It's also in the base position for the exponential. All that happened was that it was with the 1/4. Now it's with the 1. Simple as that. So b to the power of 1 is just b, and then 1/4. So b is 1/4. This question over here says determine the value of m. So we know that this point over here is 1 and 0. And so you can just go plug that into this equation over here. So we know that k of x is equal to mx minus 3. And so if you had to go plug in 0 equals to m times 1 minus 3. And so if you had to go solve this, you would eventually find out that m is 3. 5.4. This one says write down the domain of f. So domain is all of the x values. So for a normal log graph like this that hasn't been moved left or right, we know that it has an asymptote on the y-axis like this. Okay, and then so it can go all the way to infinity on the right, but as soon as it tries to go to the left, it gets caught up, or it gets stuck with this asymptote. Okay, so it can never go past that asymptote. So for the x values, we will say that it goes up to the asymptote of 0. Now we never include a 0, and then it can go all the way to infinity. If you rather prefer to use the other method, you could just say that x must be bigger than 0. Because remember guys, on this y-axis, what is the x values on the y-axis? The x values on a y-axis are equal to 0. So we're saying that the x values of this graph must be greater than 0. And now, so that's done. And remember, we do have more questions coming up. So this one says, determine the equation of the inverse in the following form. Very easy. So we know that we have an equation for f, which is log of b, which is a quarter. Now to find inverse, step 1, switch x and y around. And then step 2, get the y by itself again. So here we're just going to use that the base stays the base again. So here we've got the quarter currently with the y. All we're going to do is just write the quarter with the x. So we're just going to have a quarter as the base with the x. And there we go. And so we can just say here that y is equal to a quarter to the x. This one, determine the values of x for which this expression. Okay, pretty straightforward because we've just gone and worked out the inverse equation, and what we found was that it's a quarter to the x. So I'm going to go and take a quarter to the x, and I'm just going to go and put that in between here, because what I see is that, you know, we've got a lot of these 4s happening. So I know that 16 is the same as 4 to the power of 2. Now, I know that I can write this as 4 to the negative 1, and I can write this one as 4 to the negative 1 as well, but then it also has that x, so I'll just put it in a bracket, and then I'll leave this one as 4 to the 2. So that's 4 to the negative 1, and then this becomes negative x, and then this just becomes that. So what I notice now is that we've got 4s everywhere, so I can just ignore them, and so I end up with minus 1 smaller than negative x, smaller than or equal to 2. To get x alone, I'm going to have to divide with negative 1 to get rid of that negative. But because it's an inequality, whenever you divide with a negative, the signs are going to have to change. That's going to have to go like that. And that's going to have to go like that. And so there is the answer. X can be any number bigger than minus 2 and smaller than or equal to 1. This last one says, sketch the graphs of the inverse, okay, and also sketch that one on the same system of axes clearly indicate. Okay, this is a super easy question because what we need to remember is that when you have inverses, the x's and the y's simply change. So if I have to go look at the graph of f to the -1, so it's the inverse, then all I do is I just take this coordinate and I just switch the x and y around. So it goes like that. And then I remember what D's coordinate was. It was 1 and 0. So 1 and 0. That just becomes 0 and 1. Let's just write that a bit better. And so let's go quickly do that for that one. So I know that 1/4 and 1 turns into 1 and 1/4. So that's going to go 1 and 1/4, which would be like there. And then 1 and 0 turns into 0 and 1, which would be there. And then remember, this was the original asymptote, which was x equals 0. Now it's going to be on the x-axis, and we call that the y equals to 0 line. So it's going to be a graph that goes like that. Obviously, it's supposed to go through this point. Okay, and then they said, please show any intercepts. So this would be 0 and 1. Now we also have to go sketch the graph of k of -1. So we'll use the same technique. So at the moment, on the graph of k, we have the coordinates of one of its points. So we can just change that to 0 and 1, because once again, when you go from an original graph to its inverse, or vice versa, you switch x's and y's around. That's all that you do with inverses. Now we need one other point. So let's go find out the y-intercept of k. So we know that when you find a y-intercept, you make x equal to 0. So if we had to go make x 0, remember we found its gradient as 3 in one of the previous questions, and that would give us -3. So that means that the coordinates here would be 0 and -3. So if we had to switch those, it would go to -3 and 0. Okay, so now we can go and plot these 2 points. So 0 and 1 would be here, and then -3 and 0 would be over there, for example. Okay, now they haven't really drawn their original graphs according to scale. So yeah, if we did have to go and connect these, it's going to do something like that. But in real life, these 2 lines wouldn't look like that. If they were inverses of each other, you would see more of this type of shape. You would have the original graph, and then the new one would be something like that. And so you'd get that kind of shape if it was all drawn according to scale. So if that bothered any of you that these 2 lines almost look like they're parallel, it's just because they haven't drawn their graphs according to scale. Now we just have to go and put the coordinates, and then we've got those. Johnson deposited an amount of 10,000 Rand into a savings account that pays interest at 7.15% compounded quarterly. Calculate the effective interest rate. Okay, so you know, guys, in grade 11, we learned about a formula where you can convert between effective and nominal. And so you'd get this formula that goes 1 plus I effective equals to 1 plus I nominal, and then typically at the bottom here you'll see M and M, or some textbooks use different letters, but it's this formula. Okay, and so they want us to calculate the effective interest rate, so this is the unknown, and then we can take the nominal, which is the monthly, quarterly, whatever, and that's 7.15%, so I'm going to say 0.0715. And then because it's quarterly, that means 4 times in a year, so that's going to both be a 4 over there. And now what you do is you just get the I effective alone, so you don't want to round off in these questions until the very end. So what I do is I take that 1 and I take it over, and then I'm literally now going to go and type all of that on my calculator, and then before I round off, you're going to multiply with 100 to convert it into a percentage. Don't round off until you've multiplied with 100. Okay. And so you should get 7.34%. If you round off before multiplying with 100, your answer will be totally different. Okay, so you only round off after you've multiplied with 100. Now it says calculate how long will it take for the investment to grow to that value there. Very straightforward question. You're just going to use your normal compound formula. We know that A is always the final value, so that's going to be this one, so 17,628,78. P is the starting amount, the interest rate. Now we'll just use the one that they gave us, so 0.0715 over 4. Now we don't know how long it's going to take, so we can, now some learners, they get confused, like should you put a 4n over here or should you just put a n? It's up to you, but you need to know what you are doing. So if you put 4n, then n is your number of years, okay? But if you rather just say n altogether, like that, then when you get your final answer, that is the number of quarters. Okay, so it's up to you how you want to do that. I'm going to go 4 times n. So then remember that n is the number of years. It's like if I told you that this was a 5-year question, you would have then said 4 times 5. So you already know that when you write it like this, that is your number of years. Okay, and so now we're going to have to solve, but we're going to have to use logs, because whenever this exponent is the unknown, we're going to use logs. And what I always tell learners is that logs are extremely sensitive to rounding off. So you don't want to round off until the very end, because otherwise your log value can change the answer completely. So I try not to use my calculator at all until the end. So what I do is the following. I know that I need to get rid of this number, so I divide it on the left. Okay, then what on the right, I type this on my calculator and it usually pops out a fraction. I leave it as the fraction. There we go, because then I don't have to write out all the decimals. So it's 8143 over 8,000, and that's to the 4n. Now, this is where we need to use logs. Notice I'm not using my calculator yet. So if you had to switch this to logs, you would eventually end up with log of 8143 over 8,000, and then 17628,78 over 10,000. Now I'm going to go use my calculator. So 4n is going to give us exactly 32 if we round up. And so then if I divide both sides by 4, I end up with n equals to 8. And I know that n was my years, and so I can say years. For learners that didn't put a 4n over here, but you just put an n, then you would have just gotten an answer of 32, but then you wouldn't say 32 years, you would say 32 quarters, and then you would just convert that to years. And you know that every quarter, in every year, there are 4 quarters, so you could always work it back. Mr. Simbin took out a home loan of 1 million rand at an interest rate of that percentage compounded monthly over 20 years. The loan is repaid via monthly installments of that amount. Determine the outstanding balance after the 125th payment. 2 ways to do outstanding balance. Because I'm a darling, I will show both. And so method 1 is using the present value method. And so we know the present value formula goes like this. Okay, but now you can just call it outstanding balance. Present value is actually outstanding balance. And so if they want to know what is the outstanding balance, okay. So you got to be careful with how we're going to use this 125, because it's different whether you use method 1 or method 2. So we know that the monthly payment is 10,492.56. We know that the interest rate is 11.25%, and that's compounded monthly, and it's 20 years. Okay, but now we've got to be careful. When you are using the present value method, the n value is the number of payments that are still, or that, let's rather say, that still need to be made. Okay, so if we have 20 years, 20 times 12 is 240. That is the total amount of payments that Mr. Simbine would make if everything runs normally. But now they said after the 125th payment. So how many payments still need to take place? Well, you would say 240 minus 125, and that would be 115 payments that still need to be made. And so that is what you would use over here. Okay, and then 0.1125 over 12. Go ahead, type it all in. And if we've done this correctly, we should get an outstanding balance of 736,498.33. Okay, now if we instead do method number two, which is where we use the future value method, then the way that this one works is your outstanding balance. You always need to find out the loan value, and then you subtract the future value of payments. So on many memos and things like that, you would see them saying A minus F. So A is your loan value, because to calculate your loan value, you simply use A equals to P1 plus I to the N. And then F is your future value of your payments, where you use the future value formula. So to then go work out the outstanding balance, we're going to replace the A with the formula, which is that. And then you're going to minus the future value formula, which goes like this. Okay, and so now we just go fill everything in. But what's important is that if you watched my method 1 technique, the N value, it's different in both scenarios. So if we had to go work this all out now, we're going to end up with, well, let's take, yeah, so all of it is going to go, I think I can fill it in here. So P is the original loan value, which was R1,000,000. The interest rate is 11.25%. Now, when you use this method, the N value is the number of payments that have already been made. So here we know that we've already done 125 payments. Okay, whereas in method 1, when you use the present value method, then your N value is the number of payments that still have to be made. Okay, and then you're going to say now the monthly installment, which is 492.56, and then 1 plus 0.1125 over 12, and we're going to say 125 minus 1 all over 0.1125 over 12. And if we had to go work that all out, my calculator nearly ran out of space there. 736,498.37. Whereas when we used the present value method, we got 736,498.33. So I've told you guys this many times. The two different methods always give very similar answers, but the sense is normally a little bit off with the two of them. Okay, so in an exam, you don't need to use both methods. You need to just know how to use one of them. Okay, so you don't have to show both methods in an exam. Okay, so moving on to the next one now. Now, just to quickly summarize, I showed two different methods in the previous question in 6.2.1. And we got two different answers for, depending on which method we chose. The two different methods always give pretty much identical answers, but the sense can often be a little bit different. Okay, so for the rest of the question, I'm just going to use this one over here. Now it says, Mr. Simbine had financial difficulties and was unable to make the 126th, 27th, 28th, 29th, 30th payments. The bank agreed to restructure the loan so that it is still paid off in the same amount of time. Determine the new monthly installment. Brilliant question, because this is very realistic as to what can happen in your own life, in real life one day. And I want to explain how the banks do it and how it works. So what happens is the following, guys. When Mr. Simbine went and got the original loan from the bank, what was the loan? How long was the loan going to be paid off? In 20 years, right? So the bank, they don't normally want to change that. They want all of the money to be paid back in 20 years. Okay. So that is usually fixed unless you make special arrangements. So the original term was 20 years, okay, which is about 240 payments because of 20 times 12. Now, Mr. Simbine, everything was going good in his life. He was making all of his payments. He even made the 125th payment. So everything was perfect. Then, for some reason, he didn't make the 126th, 127th, 128th, 129th, and 130th payments. So he missed 5 payments. Okay? So he then walks back into the bank and he says, "Hi, bank. I'm really sorry that I haven't made those last 5 payments. Um, Things got a little bit hectic on my side." Now, the bank isn't just going to say, "Oh, you poor thing, not a problem. You can just add on another you can add on another 5 months. And so instead of making 20 years, we can make it 20 years and 5 months." No, no, no. The bank is not going to say that. The bank is going to say you still need to make all of the payments back within the original 20 years. So how is Mr. Simbine going to still be able to pay back the original? How is he going to be able to pay everything back now that he's missed 5 payments? Well, what the bank does is they restructure everything and they're going to increase this monthly installment a little bit so that he will be able to catch up those 5 payments that he missed. They're going to somehow restructure everything so that his monthly installment will go up a little bit, so that by the time 20 years is complete, he has paid off the entire loan. And so that is what happens in real life. If you skip payments, the bank is then going to increase this value so that you still finish your loan in the original 20 years that they said. And guys, one day in real life, when you take out a loan, don't miss payments. The banks are actually very harsh. They will even put a black mark against your name, and so you will have a bad credit rating. And so in the future, when you ever want to borrow money again, or if you want to buy a house and you need to borrow or pay off a bank loan, if you have a very low credit score, if it gets really bad, they'll even blacklist you. Then it is almost impossible for you to get a loan again in the future because banks are no longer going to be able to trust you because you haven't shown that you can be trusted because you often miss your payments. So it's not good if you miss payments, okay? So don't think in real life, "Oh, but Kevin said it's fine, I can miss my payments, they'll just increase the value. I don't mind that." No, 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 you don't want to miss payments. The banks don't like it at all, and they'll lower your credit rating so that any other bank that you try get a loan from in the future, they will see that, and it's going to count against you. Okay, so right, let's see how we now need to go work out what the new monthly installment is going to be. So what we need to understand was that after the 125th payment, everything was going good with Mr. Sabine. So after the 125th payment, Mr. Simbine still owed, what was the outstanding balance? This one. I'm just going to use this one. For those of you that did the future value method, you can use your value as well. The memos allow for both. But he still owed 736,498.33. So after the 125th payment, this is how much Mr. Simbine still owed on the loan. Okay, so that is what he still owed. Then he misses 1, 2, 3, 4, 5 payments. So guys, what is going to happen to this value when Mr. Simbine doesn't make his payments? Remember that your loan that you still owe the bank it just keeps growing and it keeps growing and it keeps growing. And so we need to go and see what the new outstanding balance is going to be because he missed 5 months. So you can simply go and use this formula over here, and you can simply go and calculate what the new outstanding balance is going to become because he missed 5 payments. Remember that the loan is always going to keep growing. Okay, so it's going to be the original interest rate, and that is going to be monthly. And we're just going to say 5 over here. You're not going to say 5 times 12 because that would be 5 years. He only missed 5 months, okay? And so if we work that out, it's now going to be 771,675 point. Let's not round off because it's not the final answer. So guys, what happened was that after the 125th payment, Mr. Simbine, just imagine he went into the bank that day and he said, yo, what's up, guys? You know, because him and the banks are cool because he didn't miss any payments at that point. And they were like, oh, Mr. Simbine, my bro, come sit here. Do you want some coffee? How's things going? We like you. You're paying off your loan. Everything's good. And Mr. Simbine's like, yo, man, I just want to know, like, how much of my loan do I still need to pay? And they told him on that day, on this day, they told him, this is what you still need to pay on your loan. So he was like, okay, cool. And then he walked out the bank that day and something happened in his life and he wasn't able to make the next 5 payments. So for 5 months, he just didn't pay. So then he walks back into the bank and the bank's like, Mr. Simbine, please come sit down. We have to speak with you. And he's like, guys, look, I know, I'm sorry. I missed those 5 payments, but now I'm back. And so can we just carry on? Can we just use this as the loan value that I still owe? Is this still the outstanding balance? And the bank says, well, the person at the bank says, of course not. Because you missed those 5 payments, your outstanding balance has now become this value over here, Mr. Simbine. Unfortunately, we cannot just keep it like this. You missed your payments. And because of the interest and everything, we have now made your loan outstanding balance increase. So Mr. Simbine says, okay, fine, I understand. So this is now the new loan value. And now I would like to recalculate the new monthly amount so that I can still finish everything in the 20-year original time span. So the person at the bank says, fine, that's perfect. This is your new outstanding balance. Let's go and calculate your new monthly amount so that you can still pay everything back in the original 20 years. Okay, so we can now say that the new loan value after the 130th or after month 130, because that's the last payment that he missed, is now going to be 771,675.0993. So then we can actually go do a brand new loan type of question. We can just pretend that this is now the brand new loan amount, and we can just go use the present value formula now, because the present value of the loan is now 771. That is what the loan is now worth today. Okay? We don't know what the new X value is going to be. They need to recalculate that for us. We know that the interest rate is going to stay the same. But now here's where you just need to be careful. So what was the original N value? The original loan term was 240. How many months have now gone by? Well, there was 125 months of payments, and then he missed these 5 months, and so 130 months have gone. So how many months are still remaining of this original 240? There's now only 110 months left over. So Mr. Simbine now has to go and pay off this outstanding value now of the loan, but he only has 110 payments left over because there's only 110 months remaining before the 20 years has run out. Because he's already used up 130 months. 125 months he was making the payments, and then he missed 5 months over here, and so he's in total he is 130 months into the loan, And so there's now only 110 months left over where he actually has the ability to pay it off. Okay, and so the monthly and the number of payments that he now has available to make is 110. Okay, and so then we're going to close that bracket, and then we're going to say 0.1125 over 12. Okay, so what happens now is that you now need to go and get x by itself. So I like to try use the calculator as little as possible so that I don't have to worry about rounding off and blah, 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 blah. So I'm going to take this over to the left-hand side. So we're going to end up with 771,675.0993. And then we're going to multiply that by 0.1125 over 12. And then we're going to divide by all of this. Okay. And so that will allow us to get x by itself. So x will be equal to that. And so if you had to go recalculate this, we should get a value that is larger than that. And so this has become the new monthly installment, 11,273 Rand and 50 cents. You see, guys, so Mr. Simbine was only paying 10,492 Rand. He then went and missed 5 payments, and then the bank had to add interest onto that, unfortunately. And now the new installment is going to be 11,273 Rand and 50 cents, so that by the time the 20 years is finished, the loan is completely paid off. Here we have a first principles question. So all we're going to do is when you are in an exam, I want you to just quickly go and take the first derivative of this using the FOST method. And if you had to use the FOST method, you end up with negative 10x. So we must make sure that at the end of this question, that must be the answer that we get to. Otherwise, something has gone wrong. Okay, so to get the first derivative using first principles, we have to go do the whole formula. So it's f of x plus h minus f of x all over h. Okay, now we got to keep writing this limit part, and we got to keep doing it until we actually make h become 0, which only happens much later. So for the first part, it's f of x plus h. So that means that you will replace x with x plus h. Then there's a square. Then we say minus, and then we do f of x. Now f of x is just that, so you will put it in a bracket. Okay, now we keep going. And so now what some learners do incorrectly is they just try to put the minus 5 inside, or they think that they can just put the 2 inside like that, and then they say x squared plus h squared. Both of those are incorrect. What you want to do is you want to put a double bracket. There we go. Now here, if you multiply that in, that becomes plus 5x squared. And then at the bottom, we still have h. Okay, now we keep writing. This h goes to 0. Okay, now I would leave the minus 5, and then I would multiply these two brackets together. That would give us x squared plus xh plus another xh. So that's going to be 2xh, and then h squared, and then plus 5x squared over h. Let's keep going. We're now going to multiply the minus 5 in, so it's going to be minus 5x squared minus 10xh minus 5h squared plus 5x squared over h. Now here's that part that if you've ever been watching my videos on first principles, you would know what I'm about to say. At this step, everything that doesn't have an h should cancel out. If that doesn't happen, something has gone wrong, and the usual area where the mistake is over here by not putting a bracket, because then this becomes a minus, or you've done something weird over there. Okay, so what we can see is that this and this cancel, and so now we can go to the next part, limit as h goes to 0, and then we're going to get minus 10xh minus 5h squared over h. Okay, all you do at the top now, take out a common factor of h. Kevin, can't I take out more? You can, but you don't need to for these first principle questions. It actually ends up it doesn't help in these scenarios. So just take out the h, and then you're just left with minus 10x minus 5h, and that's all over h. All that we want now is for this h and this h to cancel. And so what we are now left with is minus 10x minus 5h. Okay, so the reason that we couldn't, we couldn't let h go to 0 in the beginning was because you see how we have a h in the denominator. So anytime, if you just plug in a 0 there, then your denominator would be 0, and that's a problem. But now we've cancelled it out, and so now we can go and let h become 0. So you don't need to write the limit as h goes to 0 now, because we are letting h become 0. And so you just end up with minus 10x, and that's exactly what we said over there. Here we need to go and find the first derivative. Now, step 1, you need to simplify this first, okay? So we're just going to say y equals for now. Now you need to identify that this is actually a grade 10 difference of cubes. So I'll quickly remind you by doing a different example. Let's do plus 8. Okay, so the way that it worked in grade 10 was, let's give ourselves a bit more space. So step 1, you have a small bracket, and then you have a larger bracket. So all that you do is you take the cube root of that, which is x, and the cube root of that, which is 2, okay? The next thing you do is, this will be x squared, because it's, if these two are multiplied together, it needs to give us that one over there. Then what you do is you flip the sign of what you see there. You then multiply these two parts together, which is 2x. And then lastly, you square this number, and it'll always be a positive, plus 4. Okay, so that's what we have so far. And so that's how you would factorize something like that. Okay, so if we have a situation like this now, it's going to be small bracket, bigger bracket. And so once again, you take the cube root of that, which is x, the cube root of that, which is minus 3, and this will be x squared. You then flip that sign, so it becomes positive. You then multiply just those parts together, so it's 3x. And then you square this number, so it'll be 9. This will always be a positive, as I said. Now, these parts here can cancel. Notice that we haven't taken the derivative yet, so I'm not saying dy over dx. Now we are going to go take the derivative, and so now we can say dy by dx. And now you just use that FOST method where this multiplies in the front, and then this multiplies in the front, and then it just becomes that. And then the 9 falls away. And so that is the answer. Okay, we have to take the first derivative, but at the moment we can't do anything. Well, we can't take the first derivative. We first need to simplify. And so we'll just keep saying dx. Okay, so what we'll do is just multiply the x inside. So that'll become 4x. And then you'll multiply that into there. So if you have x multiplied by x to the negative a half, exponent rules tell us that you must add. So if you had to add that on your calculator, it'll actually just give you a half. So it's going to be x to the half. Now we can go take the first derivative, so we don't have to say dx anymore. So what is the derivative of 4x? It just becomes 4. And then here you're going to multiply this half down to the front, so it'll become a half. Then you're going to subtract 1 from here, which will become negative a half. And there's your answer. Here we have a nice little 5 marker. Let's see. Given that f of x is equal to that and x is greater than 0, determine the value of a if that. Okay. So let's try to break this all down. So they tell us that when you take the first derivative and you plug 4 into that. So let's go find that first. Let's go work out what that'll give us. Or let's just go take the first derivative so long. So to take the first derivative, you just multiply the 2 into the front, so it becomes 2a. You then subtract 1 from there, so it'll just become x to the 1. Then they said that if you plug an x value of 4 into that, so let's go plug an x value of 4 into that, then that'll just become 8a. Okay, so this part here is equal to 8a. Now let's go work out this part. So they want us to go take the inverse and then plug x equals to 1. So we know that the original equation is y equals to ax squared. That's this one. Now to take inverses, we've learned by now that you switch x and y around. You then get y alone again. So you're going to end up with x over a, and then you need to go and get the y by itself. So we're going to say y equals to plus minus the square root of x over a. Now, the minus one is not going to be valid. Let me explain why. They told us in the very beginning that the domain restriction is x is greater than 0. So for the inverse, remember x and y change. So for the inverse, that would say y must be greater than 0. Because remember, when you do inverses, x and y change place. And so they're saying that the y values must be greater than 0. So the y values must be positive. So we're saying here that y is equal to positive and negative of this. But we know that everything inside of a square root is positive. So this expression is positive, and we want this whole expression to be positive because they said y can only be anything positive. So then we can't have the negative in the front. Because if you have a negative in front and this part is positive, then this expression is negative, and we can't have that because of that. So we only want the positive. So we only want that. Okay? Now they said that when you plug x equals to 1 into there, so let's go plug x equals to 1 into there. Now they said that that expression is then equal to, or let's fill in, they said that this expression is now the same as that. So we can now say that 8a is equal to the square root of 1 over a, and now we just have a square root equation. Square both sides, so that'll become 64a squared, and this will just become 1 over a. Now in maths, whenever you have a situation like this, you can imagine that this is over 1, and then you just do cross multiplication. Whoops. And so this is going to end up going there, and this is going to end up going there. So you're going to end up with 64a cubed equals to 1. Divide by 64, you're going to end up with 1 over 64. Take the cube root, and that's going to give you 1 over 4. Given that f is equal to 2x cubed plus x squared minus 13x plus 6, if one of the x-intercepts of f is 2, determine the other two x-intercepts. You cannot get something easier than that. We've learned now in grade 12 how to take a cubic equation and how to factorize it so that you can find all of the x-intercepts, right? So normally, if you were given f of x equals to 2x cubed plus x squared minus 13x plus 6, and I said, go find the x-intercepts, what would you normally do? Well, you would normally start by plugging in a random number, and you would keep plugging in a random number until you ended up getting a 0, right? And let's say that that number was, I don't know, like x equals to 3, as an example. Then you would make a bracket, and you would say x minus 3, and then you would have to go work out the other ones. Now, they were nice. They told us one of the x-intercepts is 2. What that means is that if you had to plug an x value of 2 into here, you're going to end up with a 0. And so then what we can go and do is we can then just go and take that as our first bracket. So we'll say x minus 2. When if they tell you the x-intercept is 2, then in the bracket it's x minus 2. Just like if I have x plus 3, x minus 5, and I make that equal to 0, then if I actually go and solve, I end up with that. You see, so these numbers are always the opposite of what they are in the bracket. That's normal. We've been doing that since earlier grades already. Then we don't really know what's left over here. So this is where some learners use the block method or synthetic division, or you can use this method that I sometimes show. Okay, now learners sometimes do get a bit confused with this, so I'm going to show you a longer way of how this actually works. So what we're going to go do now is we're going to go multiply these two brackets together. So you're going to end up with ax cubed plus bx squared plus cx minus 2ax squared minus 2bx minus 2c. Okay, now we need to compare this now. Or first of all, let's put all the x cubes together. So it's just that. Then we're going to put all the x squares together. Okay. Then we're going to put all the x's next to each other. and then we're going to be left with the minus 2c at the end. Now we want this to be the exact same as this. It's the same thing, right? Because here we're just trying to factorize it and break it down. So I'm going to now go and take this and write it underneath. Okay, so what it means then is that this part has to be the same. These have to be the same because they are the x squares. These have to be the same because they are the x's. And then these have to be the same because they are the constants. So if you look there, can you immediately see what a has to be? Nice. A has to be 2. So we can say a must be 2. Then if you look here, you can immediately see what c needs to be. You just need to know that minus 2c has to be the same as 6. And so c is going to end up being negative 3. Then, to find b, which is the only unknown because we found a now and we found c, to find b, you can either make an equation out of the x squares, or you can make an equation out of the x's. It's completely up to you what you want to do. I'm just going to choose these ones over here. So we'll say bx squared minus 2ax squared equals 2x squared. Now we can ignore the x square parts. So then this will just be a 1. And then we can say b minus 2. Now a we already know is 2. And then if you had to go solve this, you'd end up with 5. Okay, so we've now worked out our a value as 2. We worked out our b value as 5. And we worked out our c value as negative 3. And so now what we can go and do is break this second bracket down a little bit further. So you can use the quadratic formula, but I think this one is going to factorize quite nicely. I'm going to put a 3 here and a 1 here, a plus here and a minus here, because then I get 2x squared plus 6x minus 1x, so that's where I'll get the 5, and then it'll say minus 3. Yeah, that works perfectly. So now we can go get all of our x-intercepts. We can say x minus 2 must be 0, or 2x minus 1 must be 0, or x plus 3 must be 0. And so therefore, x is 2, or x is going to be a half, or x is going to be minus 3. So there we've gone and found, they said if x equals to 2 is one of the x-intercepts, then what are the other two x-intercepts? It's x equals to a half and x equals to minus 3. This question here, super easy marks. Determine the coordinates of the turning points. So if you have a cubic graph, or any type of graph, how do you find, or specifically on a cubic, like what have we learned? How do we find a turning point? The turning point is where, can you see if you had to draw a tangent over there at the turning point, what is the gradient of that tangent? It's 0, right? You can see it's a completely flat line. So we know that at the turning points, the gradient of the graph is 0. And we know that another name for gradient, because let's just rather talk about this. We know from like earlier grades, like grade 8 and 9 and 10, that if you have a straight line, then to calculate gradient, we use y2 minus y1 over x2 minus x1. But this only works for straight lines. But now in grade 12, we're not talking about straight lines. We're talking about curves. So how do we find out the gradient? Like, what do we do? Well, that is where calculus gets involved. And we know that the first derivative actually means gradient. Please remember that. First derivative means gradient. And we know that at a turning point, the gradient is 0. So that means if we want to find the turning points, we can go find the first derivative of that expression, which would end up being 6x squared plus 2x minus 13. And that I got by just using the FOST method, okay? Now we said that to find turning points, it's where the first derivative must be equal to 0. So we make it equal to 0. And now we're just going to go and solve this. So you can try factorize. I'm just going to use the quadratic formula. I'm feeling a bit lazy to factorize. I don't even know if that one would factorize nicely. And so remember that this would be your a in this equation, this would be b, and this would be c inside this equation. And so if we're to go fill that in, it's minus 2 plus minus 2 squared minus 4. Now a is 6, C is minus 13, and A is 6 again. Okay, and so if you had to go work out your x values there, you should end up with 1.31 or minus 1.65. Now we need to go find the y values. So to find y values on a graph, you don't go plug it back into this equation. You go plug it into the original, because that gives you y values. This gives you gradient, and we're not looking for the gradient anymore. Now we need to find the y values for these ones over here. So you're just going to go plug each of those in. So when you go plug in the 1.31, you're just going to plug it in, 31 cube plus 1.31 squared. And then just to save time, guys, I'm not going to go also show you the next one. I'm just going to write down the answers for you guys, but you get the idea. The next one, you would go plug that number in. And so for 1.31 or 1.31, the y value will be negative 4.82. And then for this one, when the x value is minus 1.65, then the y value should be 21.19. Okay, this question here says, draw a sketch graph, label all the intercepts and any turning points. Cannot get easier than this, because we already have the x-intercepts, we already have the turning points, so we probably just have to go get one more value, which is the y-intercept. Okay, now remember that these graphs don't need to be drawn according to scale, so you don't need to like go draw 20 centimeters down on your ruler or whatever. Okay, so the first, we've got an x-intercept at 2, so let's say that that's 2, and then a half, which would be there, and then minus 3, which would be like there. Okay, and then we've got turning points at 1.31, so 1.31 would be somewhere in between here, and negative 4.82, so that would be like over there, for example. And then this is negative 1.65 and 21.19, which is like there. Okay, and then obviously we'll fill those coordinates in now. We also just need the y-intercept. So to find a y-intercept, you make x 0, and you would eventually end up with 6. So that's going to be the y-intercept. Okay, now I'm just going to try to draw a curve through all of this. Okay, and then we'll obviously just go and give the coordinates. So this is 1.31 and negative 4.82. And then this one is negative 1.65 and 21.19. And this is 0 and 6. Okay, now this question here says determine the values of boom. Okay, so these are really straightforward, because remember that method that I've showed. So all that they're saying is that this part multiplied by this part must be negative. Remember, this is smaller than 0. So how do you multiply two things together and you get a negative? That can only happen if this is positive and this is negative, or this is negative and this is positive. So those are the two different scenarios we need to go and examine. So we've got the first scenario where we'll say this one must be positive and this one must be negative. That's scenario 1. Then scenario 2, we'll say where this one is negative and this one is positive. Okay. So then what we do is ignore this part for now, and let's start with scenario 1. And then inside scenario 1, let's only go and look at this part first. So what that part tells us is where is the first derivative, which is gradient. Remember, that means gradient. Where is the gradient positive? Now remember, positive gradients are when it goes up like that, and then negative gradients is when it goes down like that. Okay, so on the graph, where do you see positive gradients? Well, that would be all of this, and then all of that. Those are the areas where there is a positive gradient. Now, only looking inside those areas that are in yellow, is there a place where the second derivative is negative? Now, Kevin, what does the second derivative actually mean? Because we know that the first derivative is the gradient. What is the second derivative? Aha. So guys, remember that second derivative it tells you about the shape of a graph. Okay, shape. and we've got two main shapes. We've got concave up, which is when you have the second derivative is a positive, and it's where it makes a smiley face. So think about people who are positive are having a smiley face, and they always feeling nice and up about life. Okay, then you get the second type, you get concave down. Now this is when your second derivative is negative and sad face. So think about people that are always feeling down, they're feeling negative, and they look sad. Okay, so it all matches if you think about it from human psychology. So they're saying that, oh no, we're still in this one. They're saying that in the areas that are yellow, are there any areas where you can see a sad kind of shape? So remember, your sad shape is where it's more down like this, and then your happy areas are where it's more like that. Okay, so I can see that this area here is a sad face area. Can you see that? That is a really sad face. Up to about there. Then it turns into a happy face. Can you see that it's now a happy face for all of that over there? You can see the smiley face. So is there any area where there is a sad face in the same areas where we have the yellow? Well, yes. We can see that there's a sad face area here, and we can see that there's also a yellow over here. So that is the area that we want for this answer. Okay? Because once again, this is a sad face area up to there. But can you see that the yellow and the sad face area are existing together for this piece here? Okay, and then we don't want this as part of our answer because this area was a happy, so it wasn't concave negative, it was a concave positive. So we don't want that because we wanted it to be where this is positive and this is negative. So this area is not part of our answer, it's only this area here. So that is going to be our first answer, all of this. Okay, so how do we write that mathematically? Well, that is when x is smaller than negative 1.65, which is the x value over here. If you prefer interval notation, you could have rather said x is an element from negative infinity up to negative 1.65. Now that's just our first answer because remember we only looked at scenario 1. Now we need to go and look at scenario 2. So let's block this one off now and let's go look at this one now. So now we are going to go look for areas where the gradient is negative. So that would literally be this piece in the middle here. Okay. And we also want to find out where is the graph smiling. So we said the graph is smiling probably like somewhere from about there and onwards. So there is a little bit of an overlap. Can you see that? There is a overlap in that piece up to there. But the problem is we don't know exactly where the graph switches over from being happy or from being sad to being happy. Because we know that it's sad over here. And then we know that it's happy over here. But we don't know exactly where the switch happened. Okay, so that place where a graph switches from sad to happy or happy to sad is called the inflection point. And the way that you find the inflection point is you take the second derivative and you make it 0. Because when the second derivative is positive, we call it concave up. When the second derivative is negative, we call it concave down. But if you want to find out the place where it switches from the one to the other, then you make it equal to 0. So if we then go take the second derivative, well, to do that, we need the equation again. So we'll go take the first derivative, and that's going to give us 6x squared plus 2x minus 13. And then to take the second derivative, that'll be 12x plus 2. And we said that we'll make that equal to 0. And if you have to solve this, you would eventually end up with x is negative 1 over 6. So that means the x value, where it switches over, has an x value of negative 1 over 6. Okay, so where is the graph with a negative gradient and also smiling with a smiley face. So we said it's this little area here up to there, but we didn't know exactly what the x value was where it switches over here. And we've just found out that it's negative 1 over 6. So we can say that it's from negative 1 over 6 up until this x value here, which is 1.31. Okay? Now I know that some of you are probably wondering why we went from here only up to here. Why didn't we carry on this side? Because remember, we are looking for areas where the gradient is negative, and the gradient is only negative up to there. So we wouldn't include this part as well, because there the gradient is positive, and that we only looked at in this scenario, okay? But now we are in a scenario where the gradient has to be negative, so it's only that portion over there. And so if you wanted to write this in set border notation, you would say x is bigger than negative 1 over 6, but smaller than 1.31. So the two answers that you need to give, or if you do set border notation, you're going to say this or this. And then if you do interval notation, you are going to say this or this. Okay, so you just choose the way that you like to write your answers. A drinking glass in the shape of a cylinder must hold 300 centimeter cube of liquid when full. The height of the glass is h and the radius is r. First question, show that the height of the glass can be expressed as follows. So that 300, guys, that is a volume. So they're telling us that the volume of the cylinder is 300. Now, of a normal shape like this, any type of basic shape, the volume is always equal to area of base times height. That is the that is the volume formula for any basic shape. The only time we need to modify that is if it's like a pyramid where it goes like this, or like a cone, wherever it like comes to a single point like that. Then you'll notice that the formula changes to 1 over 3 or a third in the front. Okay, so 300 is going to be equal to, now, area of the base. Now, if you look at the base, it's this bottom piece here. What is that? It's a circle. And what is the area of a circle's, what is the formula for the area of a circle? It's pi radius squared. And then we just have to multiply that by the height. Now, they want you to get the height by itself. So you just divide by pi r squared on the left. And there we go. It said, show that that can be expressed as that. And we've done it. Next question. Hence, determine the value of r for which the total surface area of the glass. Okay, so it's really important that you guys understand your formulas, because optimization is one of the easiest chapters or sections I have ever seen, but the learners get tripped up about the fact that they don't know their formulas. And so go watch videos on measurement and where you can actually learn the formulas and understand where the formulas come from, because there's a little catch in this one. And the catch is the following. Some of you probably just went and looked at some generic formula for the surface area of a cylinder, and you would have seen 2 pi r squared plus 2 pi r times height. Well, guess what? That's not going to work for this question, because this question is a glass with water in it. So you're not going to include this part at the top, because that's not how a glass is. There's no glass over there. The glass is only the stuff on the outside, and at the bottom, there's glass at the bottom, but there's no glass at the top here. And so this formula wouldn't work. But that is what the textbooks would tell you is the formula for a cylinder. But that includes the top. So the way that I do these questions is I never memorize formulas at all. What I do is the following. I know that surface area is all of the area on the outside. So I know that I've got a circle at the bottom. So I'll say pi radius squared. And then I've got all this stuff on the outside, all of this on the outside of here. How do I even get the area of that? Well, what I do is I look at what is this in a circle. What do we call this part? The part that goes on the outside. That is called the circumference, right? And the formula of the circumference is 2 pi radius. Now, what if I had to take that and then multiply that by the height? wouldn't that give me everything on the outside all the way to the top? Yes, it would. And Kevin, I mean, some of you are saying, Kevin, but doesn't that include this part here? No, look carefully. I'm taking the outside and then I'm multiplying the outside, that part, by the height. So it's giving me everything on the outside of the shape. It's not giving me the inside part like that. It's everything on the outside. So I say 2 pi radius, and then I multiply that by the height. And that's what gives me that outside part. So this part here is the circle at the bottom. And then this part here is the outside part on the outside of the glass. And that's why you can see that these two formulas are not the same, because in a textbook, they'll put a 2 over here because they have two circles. They have a circle at the top and they have a circle at the bottom. But because of this question and the context is that it's a drinking glass, then you must remember that there is no glass at the top. And so you wouldn't have a 2 here. You would only have one circle. And that's what I've got here. Okay. Now, they want us to go find the minimum surface area. Whether they say minimum or maximum doesn't change the way that you do the question at all. So we're going to go fill in what we can here, because at the moment we have a bit of a problem. Because remember, to find minimums and maximums, we want the first derivative to be equal to 0. But we cannot take the first derivative right now. Why? Because we have two variables. We've got r and we've got h. Now some of you are like, yes, and we've also got pi. Pi is okay, guys. That's not a variable. Pi is just a constant. It's actually just a number, 3.1, blah, 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 blah. So we don't need to worry about pi. But the problem we have is that we've got r and h. But that is exactly why they asked you to do question 9.1, so that we can replace the h with 300 over pi r squared. Okay, now before we take the derivative, we need to go neaten this up and fix stuff around, move things around and do all of that. So if we carry on, we end up with pi radius squared. Now some learners here, they're like, Kevin, must we do cross multiplication? No. What you are confusing that with is if there was an equal sign in between them. If it was like this, then you do cross multiplication. So then what do we do here? Well, here you can cross cancel, or you can just multiply the top and the top together. So that's going to be 600 pi r, and then you're going to multiply bottom and bottom together, which would just be pi r squared. And so this is going to end up giving you, the pi's are going to cancel, so that's cancel, cancel. And then one of this r is going to cancel with one of these r's, and so you're going to have 600 over r left over. And so now we still can't take the first derivative. The next thing we need to do is take that r to the top, like that. Okay, now we can go take the first derivative, so we can show it by going like that. And then this 2 is just going to multiply to the front, so it's just going to become 2 pi. And then you subtract 1 from here, so it just becomes r to the 1. And then you're going to multiply this minus 1 with that, so that's going to become minus 600. And then you're going to subtract 1 over there. The next thing I would do is I would move that r minus 2 back down again. And so now what we need to realize is that whether they are asking for minimums or maximums, you always make the first derivative equal to 0. And so we're going to say 0 equals to 2 pi r minus 600 over r squared. In these scenarios, take this part over to the left. So we end up with 600 over r squared and then 2 pi r over 1. And now we can do cross multiplication because there is an equal sign. And so this is going to multiply up here. And then this is going to multiply with that. And so we end up with 600 equals to 2 pi r cube. Now to get the r alone, you're going to divide by 2 pi. And then you're going to take the cube root. And so you end up with that. And so if you had to go and work this out, you end up with 4.57 centimeters. Events A and B are independent. They give us the probability of A and the probability of B. First question, represent the given information on a Venn diagram. Indicate on the Venn diagram the probability associated with each region. Okay, so we know that there's two events, A and B. So let's just go A and B. And firstly, we know that they are independent. They tell us that. So when two events are independent, then you are allowed to use the following formula. Probability of A and B is going to be probability of A multiplied by probability of B. And so that's going to be equal to 0, 0,3 multiplied by 0, 0,6, which is 0, 0,18. So where does this go on the diagram? Where do we find this on a diagram? So let's say, or where are the things, well, let's say A was like someone who enjoys, what can we say? Someone who enjoys pizza, and then these are people who enjoy burgers. So these people over here in this area, they only like burgers. These people, they only like pizza. But these people, they are the people that like pizza and burgers. So the and is the middle, okay? So we can put 0.18 over there. And then let's just go back to A and B. Now, they told us that the probability of A altogether is 0.3. So it means that all of this is 0.3. So then you can say 0.3 minus 0.18, and that would give you 0.12. And then likewise, for this one, it's supposed to add up to 0.6. So you could say 0.6 minus the 0.18, and that's going to give you 0.42. Then what you can do is you can go add up these three things together. So that would be 0.42 plus 0.12 plus 0.18. And that would eventually give us 0.72. So we know that all of the probabilities over here plus everything over here should add up to 1. So we can then say 1 minus 0.72, which is going to be 0.28. And that is going to be this part that is on the outside. Okay, now this question says, determine the probability of B only. So B only is there, so it's just 0.42. It's only worth 1 mark. And then this one says, what is the probability that something is in B or not in A? Okay, so don't try read this and wrap your head around it. Rather just use the formula that we have on our formula sheet for OR. So we know that there's this formula that goes like this. A or B is equal to the probability of A plus the probability of B minus the probability of A and B. But now we'll just adapt, because this is just the formula that you get on your formula sheet. But now we are going to replace this over here, and we were going to replace this over here. So now it's going to be probability of B or not A, okay, is then going to be equal to the probability of B plus the probability of not A. So now I'm just copying the way that this formula works, but I'm using these now, okay? Minus the probability of B and not A. Okay, so now let's go see how much of this we can fill in. So probability of B, we already have that as 0.6, plus the probability of not A. So what is the probability of not A? So here's A, so let's block it out. So not A would be that and that, so that would be 0.7 minus. Now we have to subtract the probability of B and not A. So where are all the things that are in B, but they're also not in A? So it must be in B, but it also mustn't be in A. So that would be this area over here, this part here, right? Does that make sense to you? It must be in B, okay, so it must be in B, but it also must not be in A. So we can't include this little 0.18 part because it's not allowed to be in A. So then it will just be that part there. So we just say minus 0.42. And now we can just go add this all up and see what we get. 0,88. So whenever they give you a formula with OR and it looks really weird, just go use the base formula that they give us and then just go and adapt it to the things that they've given you over here. The digits 0, 1, 2, 3, 4, 5, 6, and 7 are used to create 4-digit codes. First question for 1 mark. How many different codes are possible if the digits may be repeated? Okay, so let's say we've got a 4-digit code that we have to make. Now, for the first option, how many numbers or how many options do you have? Well, you've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then for the next one, how many do you have? Well, now you still have 8 because they said digits may be repeated. So that means you can just keep choosing from the 8 numbers that we have available. And so if you had to go work this out, you get 4,096. Okay, this one says that if the digits may not be repeated now how many codes can you make? Okay, so this is now number A. So we still have 4 options. Well, we still have 4 digits that we have to make. So for the first option, you have 8 different numbers that you can choose from. Now, let's say you chose the 7. So how many numbers are you now allowed to choose from? Now you only have 7 available. And let's say you chose the 3. So now how many do you have available? Now you only have 6. Let's say you chose the 5. And so how many numbers do we now have left over? Now we still have 5. Because now the digits may not be repeated. So if you had to go work this out now, 1,680. This last one for 5 marks. Calculate the probability that a code will be a number between 2,000 and 6,000 and it's divisible by 5. Okay, so what I would want you to do is just quickly make a bunch of examples for yourself that actually work. For example, the number 3, 4, 2, 5. That one works because it's a number between 2,000 and 6,000 and it's divisible by 5. Numbers that are divisible by 5 end in a 5 or a 0, okay? Here's an example that won't work. Well, let's do this. Let's say will work. And let's do won't work. So a number that won't work would be like 1670, because this is a number that is smaller than 2000. It needs to be larger than 2000. Let's do another one. So the number 5310. That works because it's between 5,000, it's between 2000 and 6000, and it ends in a 0, so that's valid. A number that won't work would be 6135 because it's larger than 6,000. Okay. Also, if you started a number with 7, it also won't work. Okay. Now, this wouldn't work. 3104 because that's not divisible by 5. It needs to be divisible by 5. Okay. So this can only be a 5 or 0. Okay, so we're getting a guideline of the kind of numbers we can use, but there's still a little bit of a catch with this question. Okay, let's just make a few more that will work. So we could start with the number 4. We could put something like that. We could start with the number 2. So we could say 2510. And then a few more numbers that wouldn't work. If we started with no, we've kind of covered the scenarios that wouldn't work. So there is one little catch. Maybe some of you have thought about it already on how we can calculate this really quickly. So what we have so far is that the only numbers that are going to work in the first position is going to be the number 3, 5, 4, and 2. So those are the only numbers we can use. 3, 5, 4, and 2. Those are the only first digits that we can have. So you might be tempted to say, oh, okay, so that means we have 4 different options over here. But we need to be a little bit careful. Now the next, because there's a little catch coming up. Now the next restriction is that it has to be divisible by 5. So the only numbers that can go here are going to be 5s and 0s, right? So there's only 5s and 0s. So you might just be tempted to say, okay, well, Kevin, this is easy. For this position here, there's going to be 4 options available. And then for this option here, there's going to be 2 options available. But that's almost correct. But what about the following problem? What if the number that you chose in the front here is the number 5? What if you chose the number 5 over here? Then how many options do you now have available here? Because you're not allowed to use a 5 again because digits can't be repeated. So then you would have to say, okay, there's only 1 option available here. Okay, that's correct. But then what if we didn't choose a 5 over here? What if we chose the number 3? Then how many options would we still be allowed to use here? Well, now you could still use both of these because none of them have been used over here. So how are we going to separate the 2 different scenarios? Because if this number in the front is a 5, then it affects how many numbers we can use here. And if the number in the front is not a 5, then it means we have more numbers we can use over here. So how do we do this in one calculation? Well, this is what we do. We need to go and make 2 scenarios. So scenario 1 is when the first digit is a 5. And then we'll go calculate that. And then the second scenario, or let's go do that once along. Well, let me just quickly write over here. The second scenario is that the first digit is not a 5. Okay, so for the first scenario, boom, 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 boom. The first digit is a 5. So how many 5s do we have available? Or like, if they say that the first digit is a 5, then we only have 1 of those available. Okay, that is how many options we had over there. Now, you don't want to go fill in these ones and these ones. You always need to fill in your restrictions first. That is very important. We always fill in the restrictions first. So the next restriction is here at the end, okay? So if we've used a 5 over here, then how many options do we now have over here? Well, we only allowed to use the 5 or a 0, but the 5 has already been used. So we only have 1 option available over there. Now we come back to these 2 spaces because they don't have any restrictions. So how many digits do we now have available for this? Well, we've already used a 5, so a 5's already been used. And we've already used a 0, so that's already been used. So then for this position here, we could still use the number 1, 2, 3, 4, 6, or 7. So we still have 6 options available over here. And let's say the option we chose was the 7. Then for this one here, we still have another 5 digits remaining. And so that gives us a total of 30 different possibilities over there. Now, this doesn't mean that the code is 1651, right? These numbers are not the actual numbers we're using. Those numbers tell us how many options we had. So we know that this one was because there was only 1 5 available, and this one was because there was only 1 0 available. And then we said, for this one, we pretended that we chose a 7, and then let's pretend for this one we chose a 4. Okay, and so that is an example of what the code might have looked like. But this is how many of those we could have made. So we could have made 30 different examples that start with a 5 and end with a 0. Okay, now for the next one, the first digit is not a 5. Okay, so that means out of these numbers 3, 5, 4, and 2, which we said the first number has to be, if the first digit is not a 5, then how many do we have available? Well, we could then choose the 3, the 4, or the 2. So how many options is that? That is 3 options. Okay, and let's say we chose the 4. So that's the example of what the code would look like. Then coming to the end here, if the first digit was not a 5, then how many digits do we have available for this last place? Well, we could choose the 5 or the 0. So let's say, so we have 2 options available. So let's say we chose the 5. Okay, so then the 5 has been used, and we used a 4 for this first position. Okay, so then going into the next spot, we now have the 0 available, the 1, 2, 3 there. So we have 6 options available. Let's say we chose a 7. So let's say we chose a 7. And then for the last place, we now have a possible, how many possibilities do we now have? We've got the 6, the 3, the 2, the 1, and the 0. So that is 5 options that we still have available. And let's say as an example, we chose the 6. Okay, so that is an example of what the code would look like. It doesn't start with a 5, and the last digit has to be a 0 or a 5. So then you would go multiply all of these together, and that would be 180. So then we have 30 options over there, 180 over there. So if you add those together, that would be 210. So then they said, what is the probability? So we say 210 divided by the total. Some of you might be saying, Kev, why don't we choose this one? Because we want to operate within this restriction here where they said that digits may not be repeated. And so there's a total of 1,680 of those that can be made. And so if you type this in the calculator, it's 1/8.